Today I would like to talk about inhibitory activity.
ห้องนี้เนี่ยให้เขาปิดแอร์สักพักน่าจะดีนะ
หนูให้ปิดห้องตรงนู้นแล้วค่ะ
หนาวเหลือเกิน
น่าจะดีขึ้น
Let me start by giving you some background information. Rice, or Oryza sativa, is a major source of foodstuff for the world's population, especially in Asia. Rice grain, or rice kernel, is enclosed the tough half, or husk, which must be removed. It contains fiber and silica. Under the half are the bran and germ, which are high in vitamins, minerals, oils, and various phytonutrients proposed to have health benefits. Byproducts of rice processing are rice bran and the agricultural waste product rice hulls, which protect rice seeds during growth. The rice bran fraction contains carbohydrates, oils, and proteins. The proteins contained in rice bran is about 10 to 15%, and it consists of albumin, is a water-soluble, globulin is a salt-soluble, glutamine is alkali-soluble, and prolamine is an alcohol-soluble protein. Protein hydrolysis refers to reaction to break the polymer down of peptide bond into oligopeptide or protein hydrolysate. Protein hydrolysate can be produced by acid and alkali hydrolysis, by heat treatment, and by incubation with enzyme. Enzymatic proteolysis is the most common way and green technology to synthesize protein hydrolysis in a food and cosmetic industry. Among these biocatalysis, digestive enzymes like pepsin, trypsin, and chymotrypsin, alkylate, nucleate, and flavonoid. The functional peptides from RBPH were identified and characterized with a good sort of pharmacological activities such as antioxidant, anti-inflammation, anti-hypertensive activity, and anti-diabetic. Let's take a look at this work. The aim of this work is investigation the potential of mushroom tyrosinase inhibition from rice bran proteins extracted by different extraction conditions, as well as their hydrolysis by alkylase enzyme, and the type of inhibition was determined by enzyme kinetic assay. For the experiment, rice bran protein hydrolysate preparation used the rice bran from cow homily RD15 cultivar from Surin province, Thailand. The rice bran was defaed twice with hexane 1 to 3 weight by value and air dry overnight. The defatted rice bran was extracted twice with distilled water and filtered to obtain RBP1 fraction. The residue after this step was extracted twice with 2% sodium chloride and filtered to obtain RBP2 fraction. Finally, the residue was extracted twice with 0.1 normal sodium hydroxide and filtered to obtain RBP3 fraction. The next step, all RBP fractions were hydrolyzed with alkylase enzyme. The hydrolysis was performed at 55 degrees Celsius for 3 hours. Then the enzyme was inactivated by heating at 95 degrees Celsius for 10 minutes. And then the suspension was centrifugation at 2000 G and keep supernatant for rice bran protein hydrolysis RBPH1, RBPH2, and RBPH3 of fraction were determined of the degree of hydrolysate or percentage and molecular weight of protein by SDS-P. In the mushroom tyrosinase inhibition assay, was performed in triplicate. The reaction mixture containing 20 millimolar sodium phosphate buffer pH 6.8 RBPs or RBPH at the concentration 0.524 mg per milliliter, 2.5 millimolar aldopa, and 25 units per milliliter mushroom tyrosinase. After addition of enzyme, the reactions were mixed and incubated at 25 degrees Celsius for 5 minutes. The dopachrome formation was monitored at 475 nanometers. The kojic acid at 5.7 microgram per milliliter was used as positive control. The percentage inhibition was calculated as follows equation. For the kinetics assay of RBPH on mushroom tyrosinase was performed using various concentrations of aldopa in range of 0.5 to 5 millimolar and RBPH at 0.1 to 4 mg per milliliter. The inhibitory kinetics were determined by Lie-Riverberg plots, and the inhibition constant Ki and Kis were measured by second plots of the apparent slope or intercept versus the concentration of the RBPH. Let's see the results. This table shows the percentage of yield protein and DH of RBPs and RBPH. The RBP3 show highest percentage of yield at 6.85% and percentage of protein at 22%, followed by the RBP1 and RBP2 respectively. After hydrolysis, the RBPH1 and RBPH2 show increasing of percentage of yield at 2.38 and 1.66% respectively, and RBPH3 showed a slightly decreased percent yield at 5.05%. For the percent of Greek hydrolysates, the RBPH2 showed the highest value at 9.54%, and RBPH3 showed the lowest of DS percent at 3.46. This figure shows the SDS pattern of RBPs and RBPH. The riband protein extract or RBP fractions show the wide range of molecular weight, around 6 to 95 kilodaltons. After all fractions were hydrolyzed by alkylate enzyme, the molecular weight was decreased. You can see the RBPH1 show molecular weight around 6.5 to 37 kilodaltons, and RBPH2 show the three major bands around 40 20 and 30 kilodaltons. The last one is the RBPH3, show the molecular weight less than 6.5 kilodaltons. From investigation of the mushroom tyrosinase activity, all RBP fractions and their hydrolysates were used as inhibitor of the enzyme at a concentration of 0.5, 1, 2, and 4 mg per milliliter. The results show that RBP2 and RBP3 had a significant dose-dependent inhibitory effect on the enzyme activity, less than 50%. Moreover, their hydrolysate RBPH2 and RBPH3 show higher potent tyrosinase inhibitors, around 2 to 5 folds than protein extract. Also, the RBP1 and RBPH1 show inhibitory effect on mushroom tyrosinase activity less than 50%, but both of inhibitory effect on the enzyme was not significantly different. In this table show the IC50 of RBP and RBPH on the mushroom tyrosinase. You can see that RBPH2 and RBPH3 show the IC50 value is 1.92 and 0.46 mg per milliliter respectively, while the other fraction show the IC50 higher than 4 mg per milliliter. This figure shows the line-Riverberg plot in with and without of RBPH2. The plot shows the pattern of parallel string lines. The value of Vmax and Km were decreased, but the ratio of Km over Vm remained unchanged or slightly decreased. The results suggest that the type of inhibition of RBPH2 on mushroom tyrosinase belong to uncompetitive type inhibitor. The inhibition constant for free enzyme or Ki is 6.1 mg per milliliter, and the inhibition constant for enzyme substrate complex or KIS is the 4.5 mg per milliliter. This figure shows the line-Riverberg plot in with and without RBPH3. The plot shows the pattern defined lines with a different slope intersect at the horizontal axis in the second quadrant. The results show that Vmax decreased and Km remained unchanged with the increasing RBPH3 concentration. These results indicated that RBPH3 was a non-competitive type of inhibitor. The Ki and KIS of RBPH3 were 2.8 and 2.5 mg per milliliter respectively. For the conclusion, in this study, the alkylase enzyme hydrolysis was found to improve the inhibition of tyrosinase activity in rice bran protein fractions. For the kinetic study, the hydrolysis of salt solution RBPH2 showed the exhibit tyrosinase in an uncompetitive manner. Also, the hydrolysis of alkali extract RBPH3 strongly inhibit tyrosinase in non-competitive manner. These results indicate the hydrolysis of protease can be an efficient process for the recovery of bioactive compounds from the right Bran protein. So this is the end of my presentation. Thank you for your attention.
Thank you, Dr. Thaniya Wunnakup. And then is the question from our participant. The question from the floor. Okay, if not, I have the question for your. The first question is why the species rice bran that is cow homily is interesting to study in your work, and can you discuss or suggestion about the effect of different species, different variety, or different sort of rice bran on your study, on your work?
You mean why I interested in right brain, right?
Cow homily, specific on the cow homily species rice bran. Why you select this species?
Because this species very much and Thai population eat more this species.
Right. Okay. And then can you discuss or suggestion about if the effect of the different species, variety or source of the rice bands on the study? Discuss or suggestion if different type, different species or different variety and sort.
If use different species or cultivar, I think is the result is change.
What?
If I use the different species of right, the result of the inhibition of the activity is change, I think.
Oh, okay. And the next question, why protein hydrolyse exhibits higher activity than indirect protein?
Because of the enzyme. Because of enzyme alkylase hydrolysis protein, and the protein get the protein hydrolysis reveal the more amino acids that affect on the enzyme activity by change the conformation with the van der Waals and hydrogen bond with the enzyme.
Okay. Can you compare? Can you compare and discuss about protein hydrolyse and indirect protein? Can you compare two methods about preparation and the method for the difference of protein hydrolyse and indirect protein?
Compare, you mean compare with the protein and protein hydrolysis?
The method for protein hydrolysis and the method for indirect protein.
Either method for extraction, right? Or method
extraction.
I'm not the optimization of the extraction method. It is consequence step. I extract protein before and next to hydrolyze them. And use the both of fraction to take the activities.
Okay. Any question from the participant? Okay, if not question, I have a last question. Okay. From your results, you used to develop in the cosmetic formulation, right?
Maybe I will
Maybe.
use.
Okay. Can you suggest the formulation development of the usage of this preparation and why? Can you suggest the developed formulation?
I will develop in the cream or gel something help the whitening.
Oh, okay. Okay. Any question? Okay. We have about 3 minutes for the question. Okay. If not the question, thank you, Dr. Thaniya. That was a cool presentation. Okay. Please
Thank
give
you.